Okay guys, welcome back. We are moving on to the last section of notes that you will take for the year. So sit back, relax, maybe not relax, but just follow along as best you can and we'll have a good time. So our I can statement is I can find and create the inverse of a function. All right, so what is that going to look like for us? All right, so an inverse relation, all right, this switches the input and output values all right, of the original relation. All right, so remember a relation is just like a set of ordered pairs. Could be an set of ordered pairs, or it can be in a table, either or. All right, but the math definition, it goes from a comma b, and then we just switch it to b comma a. So super simple to find an inverse relation. So let's just do a couple of examples. All right. So the first one, find the inverse of each relation. All right, so for this first one, all we need to do is just switch our x and y values. So this one goes to 7, negative 4, 4 comma negative 2, 1 comma 0, negative 2 comma 2, and then negative 5 comma 4. And that's it. Super simple. All right. And then the same thing goes with, all right, a table. So I like working with ordered pairs. For me, it's easier, and I would suggest you do the same. So remember, input, this is your x, and your output is your y. So we're just going to switch these. So that becomes your x, and then that becomes your y. So we get 5 comma negative 1. We get 10 comma 0. We get 15 comma 1. 20 comma 2, 25 comma 3, and then 30 comma 4. And that's it. That is all you need to do. Okay, so real quick, you have two problems to do on your own. Same process as both of those ones right there. So once you figure those out, go ahead and you will continue on the next page. Okay. So, sorry, my bad. So we're going to go on to the next page. All right, we're going to look at inverse functions and what those are. So inverse function is the function or functions that undo each other. Okay, so it's actually really easy to find the inverse of a function, and we're just going to start out with some basic linear functions, all right, for this first part, and then move on to some nonlinear functions that will still be pretty easy, I think. All right, so step one is to set y equal to f of x. All right, step two is to switch, all right, x and y in the equation. And the step three is to solve for y, like we have been doing pretty much all year. All right, so why don't we go ahead and do an example. All right, so find the inverses of the following function. All right, so f of x equals 2x plus 1. So the first step, all right, we're just going to replace f of x with y. So y equals 2x plus 1. Next, we're going to switch x and y. So this becomes x equals 2y plus 1. All right, and then, all right, we just solve for y now. So minus 1 on both sides. So I get 2y equals x minus 1. And then divide both sides by 2. And remember, you need to divide both things by 2 over here. So we get y equals x minus 1 over 2. And I think that's the easiest way to write it. Instead of putting x over 2 and 1 over 2, just keep it as that. All right, so what is the input when the output is 3? All right, so this one's a little tricky. So, all right, in an inverse function, all right, output is the x value. All right, so we're going to plug -3 into x. All right, so it's going to be y equals -3 minus 1 over 2. So that gives us -4 over 2, which is -2. And voila, that is it. All right, so what about the next three? Same sort of process. All right. So y equals x minus 6, and then we switch those to be x equals y minus 6, and then we just solve for x, so plus 6. So x plus 6 equals y. And it's that easy. All right. Next one, we have y equals 1 over 2, x plus 3. Then we switch our x and y, so we get x equals 1/2 y plus 3. All right, solving for x, or solving for y again, but there's a couple more steps. So I'm going to subtract 3 from both sides. So x minus 3 equals 1 over 2 y, and then I'm just going to multiply everything on both sides by 2. So 2 times x is 2x, 2 times -3 is minus 6, and that is going to equal r y. All right, what about c now? All right, there, ignore that extra f of x. So y equals 3x minus 5. Then we switch our x and y to be x equals 3y minus 5. And then we just solve for y. So add 5 to both sides. All right, so 3y equals x plus 5, and then divide by 3. So y equals x plus 5 over 3. And that is it for those three problems. All right. So we're going to actually go on to the next page. All right. As soon as I flip my set of notes. All right. So find the inverse of the function. All right. And then graph the inverse of its function. All right. So I'm going to start off. I'm actually going to make a little table. All right, and remember, we typically do -2, -1, 0, 1, and 2 for these values. So what we're going to do is we're just going to plug in -2 into this equation right here. We'll find the inverse in just a second. So -2 times 6, -12, -1 times 6, -6, 0, 6, and then 12. I'm gonna plot those points. This graph right here only goes to 11, so we can really only plot -1, -1, 2, 3, 4, 5, 6, the 0, 0, and then that. I'm gonna draw a line straight through that the best I can. All right. So then we're just gonna do the same process, but I'm gonna skip this the steps, or I'm gonna combine 2 steps. All right. So I'm just going to go straight to x equals 6y, and then I'm just going to divide by 6. So y equals x over 6. All right, and if you remember, all right, to find, if we're going to plot both things, all right, all we need to do is switch the coordinates. So if that's my x, then my f of -1x which that means inverse. All right, negative. Actually, I'm just going to switch the coordinates. So if I plug in negative 12 for here, I get negative 2. If I plug in negative 6, I get negative 1. If I get in 0, 0, 6, 1, and then 12, 2. So remember, I can only plot these middle three. So negative 6, negative 1, 0, 0, and then 6, 1. And ta-da. All right. And then the last problem for the notes. So this one's actually a special case. So I'm going to again start with x and f of x. All right, but this time I'm going to go 0, 1, 2, 3, 4, and you'll see why in a second. So if I plug in 0, I get 5. If I plug in 1, negative 1 plus 5 is 4, 3, 2, 1. Okay, and now I'm going to find my inverse. So again, I'm skipping steps here. So x equals negative y plus 5. So I'm going to subtract 5. So I get x minus 5 equals negative y, and then I just need to divide by negative 1. All right, because we're dividing by a 1, all right, I can do that to both of these. So that becomes negative x and then plus 5 equals y. So if you notice, your equations are the same. So that means, all right, 0, 5, 4, 3, 2, 1. The functions are actually, or this equation is its own inverse. So should be pretty easy because you only have to draw one line. You found the inverse. The inverse just happens to be the same thing. Okay, so you have one more problem to try yourself. All right, and you're finding the inverse, and then you're graphing that in its the original function and its inverse. Okay, so that is it for the notes. All right, let me know if you have any questions. If not, all right, I will see you in the next video.